in how to avoid these risks. Anyway, how do we use this software? How do we use intelligent systems in manufacturing processes? And it's the next speaker that's going to talk to us about this, Mikel Sanchez, who's coordinator of Industry 4.0 in Tknika, one of the Basque Country's research centre.
Bueno, egunon, buenos días.
Good morning. As the previous speaker said, everything is smart. And our factories are going to be smart as well. It's the smart component that actually is behind everything that we understand as Industry 4.0. In this talk, once again, I'm going to talk about Industry 4.0. People have been speaking about this term Industry 4.0 for the last year or two. People are trying to make us aware of what Industry 4.0 is. And we think it's an important concept for the fabric of Basque industry and needs to be understood. However, let's take a step further. And I'm going to try to make this presentation as educational as possible. What I want to do is to explain things to you in such a way so that this term becomes tangible, so that you can understand the benefits of this new trend and how it should be implemented in companies. It's like a basic guide to Industry 4.0 and how to introduce Industry 4.0 in our companies. So I've structured this presentation into a first section when I'll briefly explain what Industry 4.0 is. Then I'll concentrate on how Industry 4.0 can impact our companies, because it's a difficult thing to understand. There are many sides to it. There's a philosophy behind it. Industry 4.0 always talks about increasing efficiency and creating products with greater added value. But these are headlines, major headlines. But when you try to filter them down into our companies and the specific way in which all of our companies work, it's not so obvious, not so clear how all this functions. So let's try to help you understand this through what I'm going to call a intervention map in Industry 4.0. I'm going to carry on by explaining to you what an I 4.0 project should look like, both for people, for workers, and I'll try to give you some examples in the end. Industry 4.0. As you may already know, this term emerged in Germany to refer to the fourth industrial revolution. Why is it the fourth industrial revolution? Well, because it was believed that there had been three previous industrial revolutions. The first was one when the first machine was devised to carry out some kind of productive process. In this case, for example, a weaving machine. The second was when the first production line was created, i.e. when several machines started working together on a production line. The third is when automation came, that is robots that helped us do tasks which in the past had to be carried out manually. That wasn't necessarily a smart way of doing things, but it helped us in the production line. So that's the trend that was followed in industry. So now we reach the fourth industrial revolution, but what is it all about? If you look at the headlines, it seems to be industrial revolution based on cyber-physical systems. But when people talk about cyber-physical systems, you suddenly think, hey, hang on, stop there. What is a cyber-physical system? If we're using this term, we need to understand it, of course. So what is a cyber-physical system? What we understand as a cyber-physical system is a system which takes a physical object and using ICT technologies or software can create a virtual representation of it. What I mean, for example, this table or these chairs, these are physical realities. I can sit on the chair, I can lean on the table, I can put a piece of paper and write it on top of the table. But what happens if we put a series of sensors on the chair or on the table that could measure vibrations, pressure, and all different magnitudes? If we were able to measure these and then take them to a cyberspace, which is, for example, the cloud or internet or databases that are out there that can be accessed from outside and can be attacked, as we've just heard, then you'd have the representation of the chair or the table as a thing on the cloud. So what you're doing is creating a cyber representation of a physical thing. So at the same time, that means you're creating a cyber-physical system. That's what a cyber-physical system is. And you might ask yourself, well, what's that for? Well, you can do quite a lot of things with that, because if I sit down on that chair and that chair is talking to me from somewhere, it's saying to me, I'm going to break. Hello. You're so heavy. Or I'm getting hot. Maybe you're uncomfortable. Or the table might say, well, there are 8 people with their things on top of this table and the legs are going to break. All of this means that we can create a more comfortable environment. That's just an advantage, just an example. If we take this into factories, it shows us that our machines and our machine operators can be sensorized and become cyber-physical systems. So this machine that is involved in a production process can give us with a virtual representation where we can see we can see its behavior, and based on parameters that we're measuring, we can head off breakages, breakdowns, problems, mistakes in the part that's being manufactured, or even foresee and optimize certain processes. But basically, is this digitization of all those elements that form a part of the supply chain in a manufacturing system. And we create cyber-physical systems. This is a message that that will come up time and time again in the overheads. So what are the aims of Industry 4.0? They're actually pretty obvious: cost reduction and increase in production times. But as major headlines, what Industry 4.0 wants are the followings. And this is a reaction that came about in Germany to the fact that in Asian countries, things are manufactured differently. They're mass-produced with less quality. So what they're trying to do in Europe, and this started in Germany, was to do shorter production series but of better quality. And the idea was to refine the production machine so much that costs would be reduced and we could be more competitive. So we were going to create products that have a greater added value. So it's a matter of increasing the effectiveness of our value chain. And another thing is the increase of jobs that have a greater value. That means that workers need to be more skilled and will be upskilled within Industry 4.0. What are the technologies behind all of this? I've already said that we could say Industry 4.0 is a process of digitalizing the production process, but that's a fairly broad experience. So maybe we should be a little bit more precise about the technologies that are behind this. The main protagonist, I think, well, there are two main protagonists, or maybe three of those that are up on the screen. You can see them all up there. I'm not going to talk about all of them, but basically the Industrial Internet of Things, very important thing, that, and what we're saying here is that all operators, all entities, all machines, all production lines will have sensors on them which will track data, and that data will be kept. Big data as a facilitating technology. Why do I say that? Because with the data that we record, we need to analyze that data. And then there's the issue of cybersecurity. If what we're doing is connecting all the data, putting them on the cloud, then all these systems, of course, need to be cyber safe, because otherwise we're exposed to an attack. We can be exposed to an attack. So we need cybersecurity, and we need, therefore, to take measures so that everything that we do is safe. There are other things. I'll show you other examples. For example, augmented reality, collaborative robotics. In this case, robots are going to be increasingly smart. They'll start working together with machine operators hand in hand and safely. And all of this will lead to a series of changes. And then additive manufacturing. Although additive manufacturing isn't an ICT, it is very relevant, or rather it's a revolutionary way of manufacturing, and it also has an important role to play in the Industry 4.0 universe. This is where it's all happening. As you can see, we're not just talking about factory settings. If you look at this graph carefully, you'll see there's a big orange blob in the center which represents a factory setting, i.e. where the production process is carried out. But Industry 4.0 isn't just that. It's not just a matter of optimizing production or affecting the production line or things that happen at a factory level. No, it covers the whole of the supply chain, from suppliers right up to the end customer. If we look now specifically at the customer, what you find is that the product that a manufacturing company produces, if this product is a cyber-physical system, as we defined previously, then as a manufacturing company, what we can do is monitor the product once it's being used. That is, if I manufacture chairs and I've put sensors inside the chairs, what I'm interested in finding out as a chair manufacturing is how these chairs are being used. So collecting information about how a customer is using my products is especially important in Industry 4.0, so that I can adapt to customer needs. This is an important variable, because we're not just talking here about the fact that thanks to machines, operators and production lines that are sensorized and interconnected and can act in a smart way so as to better produce an item. There's another component, and it's equally as important to Industry 4.0, which is how my products are performing when they're in the customer's hands, and how I can adapt what I produce to needs thanks to the information that I get from my customer. Having introduced the idea of Industry 4.0, and the general context, let's now look a little bit more at the Industry 4.0 map. What can you see here in this diagram? Well, what this diagram is useful is to place any action that or process for Industry 4.0 process or action that a company is going to carry out in a certain place for a certain benefit. We'll look at it now. There are 5 different fields in which Industry 4.0 can have a role to play from the bottom upwards. We've got the environment where the machine operator is. That is, we can create projects that have as the operator, the machine operator, as its as their main center of attention. The machines, the production lines, and when I talk about a production line, what I mean are a series of machines that all together with the operators produce something. The factory and the supply chain, that is up another step on the scale, or the product, in the field of the product, because the product that we manufacture is another environment that we can work on within Industry 4.0. So now that we've found the environments, that is those areas where we can act upon, what we need to define and what people are really interested in is, and what's this all for? What am I going to get out of all of this? And that's when the columns need to be looked at. And there are 8 columns. The first column means extreme adaptation of supply to demand. This is very related to what I said earlier about how, once my customer has the product, how it performs. What we want is a product that covers, that meets the needs of my customer. I'm going to make this product for you, and if I do it unitarily, even better. I always give the example of Nike running shoes. How does Nike set up its production line so that I can go into a website and have my name sewn onto the running shoes, the colors that I want on my running shoes and the design that I want, so that Nike can unitarily make this single pair of unique running shoes for me? I have to pay a little bit more, but that's what we're talking about in the first column, how our manufacturing companies can adapt their production lines to fully meet the unitary needs of their customers. The second column is a matter of optimizing human resources. This sounds a bit odd, but what I'm talking about here is basically using robots in our manufacturing processes. Why? Well, to replace manual processes and that have little added value. Robotics is going to have an important role. Robots are going to start to think, but always under the supervision of a human being. They're not going to replace operators. They're going to make them better. The third column. We're talking here about the optimization of necessary consumption, such as energy or materials. This is also something that could be a driver of Industry 4.0. Fourth column is optimizing the use of assets. What do I mean about assets here? I'm talking about the machines themselves, about getting operational efficiency, optimum operational efficiency. All production managers are what they're trying to achieve. The same goes for the next column, maximization of quality, 0 defects. That means that all those products that I manufacture are properly produced and have 0 defects. Sixth column, the use of the post-sale service. If my product, which has sensors in it and is a cyber-physical system, let's remember that, if I can monitor it, I can know how it's behaving when it's being used, and in that way I can offer leverage services to this product. I can sell to the client not just the product, but the product that never breaks, which is actually a service. Why? Because I'm gonna make sure that I can monitor the product and I can make sure that the product isn't going to fail. And if it does, and I'll fail it, and I can even probably change it for you even before you ask me to do so. This is what's behind column 6. And then finally we've got maximization of safety, health and safety. In its broadest sense, when I talk about safety, I can be referring to cyber safety, safety in the environment, sustainability, and we could end up with the 8th column, which is an improvement in corporate social responsibility. I mean, a company might have as its objective within Industry 4.0 become that of becoming a driver and a driver in this idea of corporate social responsibility. So that's what I wanted to explain about this slide. And I know I've spent a little more time than normal on this, but I wanted to explain what really fits in with Industry 4.0. And when we talk about Industry 4.0, it should fit in with some of these little boxes. So how do we get involved in an Industry 4.0 project? In general, they're always the same. Then, of course, they have to be customized, but they've all got many elements in common. First step is to pinpoint everything, and we've got to find all the elements, i.e., if we're talking about cyber physical systems that are going to be connected, that are going to have sensors, that are sending data up to the cloud, what we need to do is know who's who within the whole of the production chain. So the machines have to be located, as do the operators, the raw materials that we're using. Everything needs to be labeled, as it were, and identified. The second step is to measure, because you can only improve something if it's been measured. It's always beneficial to measure things. People don't think about that. People don't always think that they need to measure, but it's always best to measure. Then you can improve something. So we're going to measure using sensor, we're going to capture data, and we're going to use those data, store them somewhere, probably in the cloud. A cloud which could be as a concept systems in our plant, or systems that are in the cloud, such as Amazon or Microsoft. I.e., we don't know for sure where this information is, but we trust that there is a solvent company that can somewhere store our data safely. You know, when the previous talk on cybersecurity just goes to show how important this is. We need to have some kind of means of storing safely our sensitive information. And finally, perhaps the most important part, because it's all very fine and dandy to measure, it's necessary. However, what we're going to do with this data that we've acquired is process them and extract from them relevant information, and therefore correct those problems that we saw in the previous table, those 8 drivers, because those 8 drivers can be attacked if we can correct problems using the data that we obtain. And how do we do that? Either visualizing data and getting an expert or operator to decide what should be done to optimize a process, and we can have artificial smart systems or big data, which is a very fashionable term at the moment, which are going to help us and do it for us. And we're always talking about decision-making support systems. We'll always be behind them. But what we can talk about is like this enormous brain that sucks in all this information, transforms it, and draws conclusions. But what we need to seek are patterns within this information that can help us solve the problems that we've pinpointed earlier. Where do we get all this data from? As I said before, we need data. Well, you can get them from machines, existing systems, in factories. I'm not going to spend much time talking about this slide because maybe it's a little too detailed. But just retain the idea that sometimes we're going to have to place sensors for data capturing, but other times it won't be necessary because the data is already there, which is just not being used. So the idea is that we get the technology to serve our companies so that this technology can solve problems with already existing information.
Fuentes.
So sources that are in the workshop, but also other sources that maybe seem not to be related, but due to the fact that there is no evident relationship, they are not seen.
Información que viene de los proveedores, información que viene de la cadena logística.
Information of the logistics plant or from the customers themselves. You can't imagine the amount of information that our customers have and that the manufacturing plants are not using to improve their processes and products. And a manufacturing company might also have the need of saying, how do I start with all of this? Okay, you've explained this to me, but how do I get started? I have no idea of what to do. There are tools for diagnostic in the 4.0 industry that can help the industry to get started and to give the first steps, saying, given my maturity level in 4.0 industry, what's my level regarding specific technologies and what are the steps to be given to get there. Some companies can do it by themselves or they can use support tools. This type of solutions exist. Tknika has one of them too, and they're usually a good path to get started. Regarding professional profiles, there's quite a controversy here. There are some articles says that Industry 4.0 is going to destroy employment. There was an article in the El País newspaper that talked about a 12% of destruction of employment, and I don't agree with this at all. But we could talk about this that comes from the Boston Consulting report. We could talk about a change in kind of employment. What we can observe on this graph is that it is true that there are some positions that will probably disappear when using these technologies, maybe more manual jobs. But we are going to create net employment in the profit loss linked to ICT systems, IT knowledge, and also sciences such as physics and mathematics. If you have children that are studying now, they should focus on this type of sciences. That's the trend now. I would also like to make a comment on training, because this is very important in this context here today. We are talking about the operators of the future being trained in a way that brings together their know-how, the knowledge of the industrial process and what they have to do at an industry level, everything having to do with manufacturing science that you see on the screen. But in the future, we would need to add skills regarding analysis of data and IT components. Saying this in general terms might seem like, well, they're going to be the super skilled workers of the future, but it's not exactly that. We're talking about hybrid profiles and people that work in teams. What is true is that we will have to know as much as we know now regarding the industrial process, But we will also need to be trained on ICT systems and be able to have an analytic capacity regarding the data gathered by our machines or robots. That should be the profile. So they should have a greater capacity of analyzing and of reflecting. Machines will never be able to substitute it, neither in the marketing sphere nor in the sphere of reflection and planning and strategy. Those skills will never be the skills of the machines, so it should be the skills of the operators. And now I would like to give some examples. Mapped with the graph that I showed before. Here you can see monitoring systems. These are systems, hardware, some of it already existing, others that could be created new, that somehow connect to our machines and make them talk. These systems can gather already existing data from our production lines and machines, and this will be very helpful to develop a strategy. Many of these systems already exist, but some companies also feel the need of developing specific systems for their own process. Where does this have an effect? On all the cells where you see a check, usually in optimization and everything that has to do with the optimization of the supply chain, of consumption, of the assets, and maximization of the quality. These systems are important, but they are nothing with the analysis, without the analysis, sorry. The monitoring systems can be used together with visualization systems, and with all the data captured, we can see this. This was it's an example shown a couple of weeks ago, and a machine tool manufacturer makes this machine to provide information using user-friendly graphs. So this would be very similar to nowadays graphic systems, because we should be aware that young people more and more are used to seeing this type of systems nowadays. So those that are children now, when they become professionals, they are digital natives. So we cannot continue with non-user friendly environments. And this is a user friendly graph, and these are parameters regarding energy consumption, performance, but they also analyze the historical data, and taking this into account, the software implements a specific artificial intelligence algorithms that can allow you to predict where our problems in the machine. Therefore, we can provide a service to the customer, letting them know what the situation is. So you not only know better your machine and your product and its operation, but you can provide an added service so that the customer, for example, changes the tool, or knowing that there's going to be a problem, so maybe you can send someone from maintenance beforehand to prevent that. Regarding big data, you see there are checks all over. What do is to take information from many different sources, probably just by analyzing this information through artificial intelligence algorithms and machine learning and all these trendy things, we'll be able to solve many problems that don't have an obvious solution. Those that have an obvious solution, well, you probably won't need any of this. But most problems are not that obvious. We are going to have all this data and information from non-structured sources, so this type of approaches would allow us to solve these problems. That's why I said before that big data is a fundamental element in Industry 4.0. Artificial vision systems for the inspection and the improvement of quality and developmental strategies, and for all the parts to be okay. Augmented reality systems. Here we can see an operator with a Google Glass, and we have the information and the task at the same time. Usually this type of technologies are applied mainly in the maintenance or in the startup of machinery, and also are used for training purposes. It doesn't have to be Google Glass. Google Glass is not something you can wear for 8 hours, neither this one or another one. But augmented reality can also be found in this type of format with other systems that allow us to see and get more information. And with this information, we'll be able to make decisions and act on it. We also want more horizontal integration between the customer and suppliers with the manufacturers to be able to know when purchases are going to be made, or to be able to manufacture even before this is requested by our customer. So following the same philosophy that I mentioned before. We don't want to have a supply problem. We want to be able to foresee what's going to happen. So if we have a greater integration from both sides, we will be able to optimize the whole supply chain in a better manner. Everything regarding safety is based on wearables. Wearables that most of us use, because I'm sure that many of you have a Fitbit or a similar device to count your steps every day. Well, these systems are going to be adopted more and more in the future. And in the case of the Industry 4.0, the most justified element or the greatest justification to use them is to avoid our operators having any accidents or incidents. We want them to work in a safe environment, and why is this? That's why this wearable technology is so important. We can also have a production control element here that is more controversial. Everything having to do with this smartization of the product. Here we have a product that has become a cyber physical product. Here we have this part. It's a bearing from a truck, and we've machined a small part, and we have inside an electronic system that measures temperature, vibrations of this bearing. What have we achieved for the manufacturer when this bearing is in a truck? To tell them, well, be careful, because my product has a small fissure and might break, so you might have a problem. And it can even measure the number of kilometers, so it could also sell these services to the truck manufacturers, and it opens the way of transforming business models. Everything having to do with cybersecurity that was mentioned before. If we open doors, and this is something general to all the devices and all the access that I've mentioned before, if we open the doors, we're exposed to being attacked. Also businesses, not only individuals. So we need to be very careful and aware of this issue. Collaborative robotics. You can see the robotic arm that you can also see on the events brochure. This was created by Tknika, and this type of systems will be existing more and more. Now it's quite common in automotive sector plants to have this type of robotized arms that carry out specific tasks. But the next step will have a double purpose. First of all, for them to be sufficiently safe to be able to interact with the operator, so that an operator and a robot could work in the same point without there being any risk for the worker, and for both of them to develop tasks. How the operator and the robot together can develop tasks that maybe the individual on his or her own couldn't be able to carry out. Maybe accessing areas of more difficult access, which would be the typical example. But what we want to achieve here is to maximize or to go beyond the limits existing in the robotic systems nowadays. And finally, and this is my last slide, everything having to do with additive manufacturing. That is not an ICT technology, but it does contribute in a significant manner. Instead of machining, as you can see there, we are creating this part with this additive manufacturing, which could allow us to be very flexible with complex and unique parts for our customers, but could also allow us to save in material. So that was everything. I hope you've enjoyed it and that you've at least understood better everything having to do with Industry 4.0 and what are the fundamental keys for it. Thank you.